This is a tutorial on point-slope form. Say we were given a slope and a point on a line. Could we use this information to graph our linear function? Well, let's look at what we have. We have a slope, which you have to remember is rise over run. So we have a slope of -2. We have a rise of -2 and a run of 1. And then we're given the point 2, 4. So let's start at that point on our graph. Here's 2, and there's 4, so there's our point. And then we would just go down 2, because that's our rise, and over 1, which is our run. So a rise of 2 and a run of 1. And there's our next point. We can do this again. Rise of -2 and a run of 1. And there's our next point. Now you connect the dots, and there's our graph of our linear function with the slope of -2 that passes through the point 2, 4. Let's try this one more time. Again, we have a slope of -4/3 and a point of -2, 6. So we're going to start at -2, 6, which is right there, and then we have a rise of -4 and a run of 3. So we're going to go down 4, and then over 3. We get a point right there. We can do this again, down 4 and over 3. We get a point right there. Again, we'll connect the dots, and there's the graph of our linear function with a slope of -4/3 passing through the point 2, 6. Well, say we were given a point and a slope and we were asked to write an equation instead of graphing. The easiest way to do that would be to use our point-slope form of a linear equation, which is this right here. Y minus y1 is equal to our slope times x minus x1. Now this may look familiar because it's very similar to our slope-intercept form and our slope equation. For instance, in our slope-intercept form, again, m is our slope, and b is our y-intercept. Now our y-intercept always occurs when x is equal to 0, and then our y-coordinate is just b. Well, if I were to plug this into our slope form, we would have y minus y1 equals m times x minus x1, and I plug this point in, we would get y minus b is equal to m times x minus 0. Well, x minus 0 is just x, so we get y minus b is equal to mx, and if I add b to both sides, I'm going to get y is equal to mx plus b. So that's how you go from your point-slope form to your slope-intercept form. Now if you look at the slope equation, if I were to multiply this by x2 minus x1 on both sides, I would get y2 minus y1 is equal to m times x2 minus x1. Now if I drop the 2's, we'll end up with y minus y1 is equal to m times x minus x1. So again, our slope equation is very similar to our point-slope form. So let's try using our point-slope form to write an equation. Here we're given a slope of -1 and a point -4, 2. Now our point-slope form is y minus y1 is equal to m times x minus x1. So we're going to plug this in for m, this -4 in for x1, and the 2 in for y1. So we get y minus 2 is equal to -1 times x minus a -4. Well, these become positive, so we'll end up with y minus 2 is equal to -1 times x plus 4. I'm going to distribute the -1 in. So y minus 2 is equal to -x minus 4. And then add 2 to both sides. And we'll get y is equal to -x minus 2. Here is our linear equation in slope-intercept form, but we got it from using our point slope form. Let's try this one more time. Again, our equation for point slope form is y minus y1 is equal to m times x minus x1. So if we plug in, we get y minus a negative 3 is equal to 3 halves times x minus a negative 2. So we get y plus 3 is equal to 3 halves times x plus 2. Again, I'm going to distribute the 3 halves in, so I'm going to get y plus 3 is equal to 3 halves x plus 3. And I'm going to subtract 3 from both sides, and we're going to get y is equal to 3 halves x. So here's our equation, again in slope-intercept form, and we got this from using our point-slope form. Say we weren't given a slope and a point, but instead we're given 2 points. Can we still use our point-slope form to write a linear equation? Well, let's look at our point-slope form again. It's y minus y1 is equal to m times x minus x1. Now, to use this equation, you need a slope and then you need a point. And instead, we're given 2 points. So the first step to using this equation is to use our slope equation and solve for our slope. So to do that, our slope is equal to y2 minus y1 over x2 minus x1. And I'm going to call this our first point and this one our second. So to plug in, we're going to get 5 minus 4 over negative 1 minus 2. So this is going to be a 1 over negative 3, or negative 1/3. And now that we have our slope, I'm going to plug that in for m, and I can pick either one of these points to plug in for y1 and x1. So I'm going to pick this one right here, 2, 4, and we're going to plug it in to y minus y1 is equal to m times x minus x1. So y minus 4 is equal to negative 1/3 times x minus 2. So this is y minus 4 is equal to negative 1/3 times x minus 2. I'm going to distribute the negative 1/3 in. So we'll get y minus 4 is equal to negative 1/3 x plus 2/3. And I'm going to add 4 to both sides. Now adding 4 is the same as adding 12/3. So we're going to end up with y is equal to negative 1/3 x plus 14/3. Let's try it one more time. Here we're given negative 3, 1, and 2, 6. So again, we have to find our slope first. So m is equal to y2 minus y1 over x2 minus x1. Now I'm going to say this is our second point, and this one is our first. So we're going to get negative 1 minus 6 over negative 3 minus 2. So we're going to get negative 7 over negative 5, or 7/5. So there's our slope. And then use our point slope form equation. Y minus y1 is equal to m times x minus x1. Plug everything in. I'm going to pick the 2, 6 as our point. Again, you can pick either one. So we're going to get y minus 6 is equal to 7/5 times x minus 2. So to clean that up, y minus 6 is equal to 7/5 times x minus 2. Again, I'm going to distribute the 7/5. So we're going to, y minus 6 is equal to 7/5 x minus 14/5. Now add 6 to both sides. 6 is the same as adding 30/5. So we're going to get y is equal to 7/5 x plus 16 fifths.